Good morning. My name is Tim Stewart, and I'm president at Visual Decisions, and we're here today to talk about how to improve planning and scheduling with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve manufacturing operations since about 2002. We help our customers combine the smart factory and the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. So with that, what we'll talk about today is how to improve planning utilizing some of these new tools that are available on the shop floor, such as IoT and machine learning and big data and all those wonderful things. And we'll go through and talk about, first of all, why we want to improve planning. I'll just spend one slide on that since I think it's probably obvious if you've signed up for the webinar. Go through and talk about how we can improve the data accuracy and completeness utilizing these solutions. Talk about execution and deviations from plan, how to improve replanning, and then talk about what would be the benefits if we get to a real-time planning and scheduling system. So why do we want to improve planning in the first place? I've actually been working with factory planning solutions for a very long time. I started off my career at Black & Decker back in 1992, and we were one of the first customers at that time of Intellection or I2 Technologies that eventually became JDA, that eventually became Blue Yonder, really we're kind of at the forefront of the advanced planning capabilities. And then I worked directly for JDA or I2 for a number of years before I got into this space with the shop floor solutions. And within there, what we saw was that by improving planning and scheduling, you can, if you had a perfect plan and you were able to execute it perfectly, you would most likely have 100% customer service levels. Unless you just have more demand than you have capacity, you should be able to, actually meet the dates that you're planning. You would be able to have minimal inventory. If I knew exactly what I was going to have to make at what given time, I could schedule those parts to arrive on a exactly just-in-time basis. I wouldn't have to carry any work in process inventory, or at least a minimal amount of it. And finished goods, I would still have to buffer for demand variability, but I wouldn't have any supply variability that I would have to buffer for. I could minimize my cash-to-cash cycle times because, again, I'm reducing that amount of inventory that I have to carry. I would never starve or block a constraint because, I have a perfect plan and I'm executing it perfectly. And then, I also maximize my critical resource utilization. So if I'm in an asset-intensive industry, I can make sure that those critical assets never go down, or at least they're always fully utilized. So obviously we want to make these things work well. So how can we make them better, or what are the things that drive them to not function at 100%? The first thing is bad data. From a planning perspective, you really do suffer from a garbage in, garbage out. If you have incorrect run times, just as a very, very basic example, you're going to suffer from an infeasible plan. If something actually takes 5 minutes to run, but our planning system is told in the data that it takes 3 minutes to run, we're not going to be able to meet the plan that it comes up with, because it's going to say, well, we can make 10 of them in 30 minutes then. And it actually takes us, almost an hour to make those 10 pieces. And so, it's going to, plan out our day and say that, we're going to be able by the end of the day to make 240 pieces or whatever it is. and we're not going to come anywhere close to that, and management will be angry with us, and customers will be disappointed and so forth. The flip side of that is that if it actually takes 5 minutes, but our planning system thinks that it takes 7 minutes, well, then it's not going to plan enough work, and we run the risk of having people sit idle or go off script at the end of the day to make stuff that they have available to them. And so either way is bad. And so we need to get those start times as accurate as, or run times as accurate as we possibly can. And it's not just run times, it's pretty much any data that's in the system that we're utilizing for planning. We have to make that data as accurate as we possibly can. The next thing here is starting conditions. If I'm doing planning 3 months out for capacity planning or long-term materials or something along those lines, what's running in the plant right now doesn't really matter. But if I'm scheduling for the next shift, I really need to understand what are the actual conditions out in the factory right now. What are the jobs that are being run? What are the, what setup am I currently running on the different machines and so forth? What inventory do I have in place? What work orders are, have actually been released out on the shop floor? What resources are available right now? What machines are down? What's down for PM and so forth? And even more, if I'm planning for a current shift, who's in today? Do I have workers that are not present, and therefore I don't have the ability to run certain operations and so forth? And so, all of those things can be very important when I'm looking at the near term part of that plan. And certainly the more information that I can feed to my planning system around these starting conditions, the more accurate of a plan it's going to be able to generate. And then, it's not just incorrect data, it's missing data that also leads to not just infeasible plans, but can almost lead to nonsense ones, and really diminishes the faith of the production team in the data that's being generated and passed to them in the plans and schedules and so forth. And so, some of the things that I've seen over the years in terms of what data is missing, components missing from the bombs are not complete that are being passed to the planning system. Tooling or fixtures that may be a constraint out on the shop floor that aren't listed in the ERP system, they're not tracked in the ERP system, and therefore they're not passed to the planning system. Those may be critical to the operation and so forth. Routing and operation steps. And I've seen a lot of ERP systems that only have the routing detailed to the credit point level, and you may have intermediate actual operations that need to take place, but they're not really called out within the ERP system. Intermediate inventory stores, different sources of demand, whether that's something that may be internal. You may be running parts for sales, you might be running parts for engineering and so forth to do tests and so forth. So you may have sources of demand that are not coming through the traditional channels that you may need to get visibility to. Different resource definitions. How many of this resource do you have? How many can it run at one time? If I run with this fixture versus this fixture, maybe I can run 6 parts at a time in this injection mold versus 4 parts and so forth. Inbound inventory is something where often you don't have the correct status on those things, or up to date based on the last pass of data into the system. Work order status, inventory holds, engineering changes. And then alternates can be something that don't show up in the planning data as well, where you have alternate resources, alternate routings, materials, bill of material structures or recipes. All of these things can be seen out on the shop floor because they happen. You actually see these things in experience over time as you're tracking what actually happens on the shop floor. But you may not see that from pure data in my ERP system that I would normally pass to my planning system. And so being able to collect this information of what really happens on the shop floor, how long it actually takes, what are all the different things that I have to utilize to make that part and so forth, let me over time build up that database and pass my planning system much more accurate information from the perspective of having this complete set of data, but also having it be correct. And so how can Industry 4.0 help with these things? Well, it really helps fill all of those different data gaps that you have within your planning information. Next, we may create what at that moment in time is a perfect plan, but who was it that said that the plan never survives past the first contact with the enemy? It's very much the same thing on the shop floor. You may have a plan that is perfect at the moment that it's generated, but as soon as it's released to the shop floor, it's no longer perfect because you have multiple sources of variation on the shop floor at all times, whether that's your personnel, not adhering to standard work and doing things off script and so forth, machines going down, variations in the machine production causing quality issues, et cetera, people or methods not being well defined, or not getting material to the right place at the right time and so forth with material handling. The materials themselves can be bad. You may have environmental conditions. Humidity might rise too high and you have to shut production down. I've seen that happen in various facilities where the environmental conditions have to be within a certain range, otherwise production has to be stopped. And that can cause different variations and so forth. And so there are a lot of different things that can happen that cause us to deviate from that perfect plan that we originally created. So I'm going to dive down a little bit deeper into a few of them because what Industry 4.0 can really help us with is to minimize or mitigate these deviations. So when we look at manpower and we look at why do our people create these variations in production? It could be low quality of information. They don't know what they're supposed to do. It could be out of date information. They're executing against something that was valid in the past, but is no longer valid. They might not be properly trained. If you see variability increase when new workers come on board, you can pretty much determine that you probably need to enhance your training or give those people more guidance in terms of how to execute on that job when they start working on it. You can, if you detect a wide variance between different operators, in terms of the operation time, in terms of the amount of downtime, how long it takes to do setups and so forth, there are things that you can do to mitigate those different sources of variation. And if you want more detail around a lot of these things, please do reach out to me after the presentation. I have a lot of different materials and a lot of experience I can draw on for how to utilize Industry 4.0 solutions to mitigate a lot of these different sources of variation. That was just the people. Obviously, the machines themselves can be a source of variation in performance. So how do you detect and mitigate downtime issues? How do you prevent the downtime from happening in the first place? How do you increase your mean time between failure? And when machines do go down, how do you reduce that mean time to repair? Those are things that Industry 4.0 is extremely good at helping with, but it's also just being aware of those problems immediately when they do occur, as opposed to when somebody pays attention and then eventually submits a ticket, and then maintenance eventually is able to respond to that. And so whether it's a downtime issue, a quality issue, et cetera, being able to identify, mitigate, or eliminate those sources of variation in machining or from machines is something that we can have very detailed conversations about. And then method as well, engineering changes, material handling, all of these different processes that support production within the shop floor. If they fail, then you're not going to have parts to run, equipment will not run optimally and so forth. And so how do we prevent sources of variation from those processes as well? And there are a lot of things that we can do with those in addition with Industry 4.0 in order to, again, identify, mitigate, or eliminate those sources of variation as well. So from an execution point of view, it's we've seen that things don't always go according to plan. And obviously we want to do what we can to mitigate those as much as we possibly can or eliminate those. But no matter how good of a job we do, we're still going to have bad materials that come in from a supplier and so forth. And so how do you create the most robust planning and execution environment that you possibly can? Well, part of that is, getting all those things right in the first place so that you create as good of a plan as you possibly can that has all the right information, the right planning times, et cetera. But it's also the ability to very rapidly identify the deviations from those plans and be able to respond and replan quickly. So that's the next thing that we're going to talk about here is replanning and how quickly you can adjust to those deviations from the plan. So why is replanning so critical in this environment that we live in that is so fast paced? It's because of those different sources of variation. As the gap between what is happening on the shop floor and what we have in our plan gets wider and wider, a lot of different things happen. So first of all, if I've got a critical resource that is counting on upstream processes to feed that material so that it can perform its assembly or processing or whatever it might be, if those upstream processes go down or have disruption in any way, then that key resource, that bottleneck in our system, our constraint, can be starved. And so when that happens, obviously we're losing production that we can't get back. We can't make up that time. We're going to have to either adjust what our expectations are, or we're going to have to run overtime, or something is going to have to be done in order to make up that gap, because being a constrained resource, that is our gating factor for the facility. Another thing that can happen is that operators go off script. So if they're expecting materials to show up and nothing shows up, a lot of times operators don't want to be idle. So they'll make whatever they can instead of what the business really needs. And often that can end up essentially being wasted capacity and even wasted materials if that production ends up in inventory as opposed to being sold. Or even worse, potentially, other operations may stay on script, even though it's no longer possible to complete those orders. So for instance, if I get a bad batch of a certain part in inventory and I identify that in part of my process, and I have to stop making that particular product that utilizes that one component until I can get replacement parts from my vendor. If the other operations in the facility continue making the other components in that final unit, they're completely wasting their capacity and potentially those materials that could be used in other end items that could be completed and shipped. And so having that visibility and having that ability to replan based on what can be done is absolutely critical. The other major impact of this is that when things start to deviate from the plan, and these problems occur, people can't make what shows up next on their schedule and so forth. Things don't show up at the right time. People start to lose faith in that scheduling process. It's like if you go to the train station and the train doesn't show up on time, you start to lose faith very rapidly of that train being there at the time that it's promised. Same thing on the shop floor when it doesn't have to happen very often that things don't go as planned, and for that schedule to say that you're supposed to run something that you don't have the materials to run, to where people start to not believe in that anymore and start to just run the things that they want to run as opposed to what the plan is telling them to do. And so if you want your schedule adherence to be good within the facility, you need to maintain that faith, which means to be able to get them things that can be executed against. So how do we actually go about doing this replanning? So there's a couple of different kinds of replanning. One is an incremental replan. And what that means is that we're only passing in those things that have changed, and we're only trying to identify the parts of the plan that are impacted by that change. So it might be materials have arrived into the building. We did a material receipt, and so we want to let the planning system know about that. It might be that a machine went down, and so we're passing that downtime into the planning system. It might be something else. We had a quality issue, a quality hold on a particular lot, and so now we want to make an adjustment in what we're doing based upon that. And so those are examples of kind of isolated effects that you can do an incremental replan for. The other type of replanning is a complete replan. Major disruptions. I had one of my critical departments go down, or that environmental issue that I talked about earlier, where this was a place that was using various powders in their production, and when you had an environmental failure to where the humidity in the building got too high, you had to shut down all of production. And so in those types of cases, you need to basically scrap the whole plan and replan from scratch. And so being able to have that flexibility of doing that partial replan, being able to do that complete replan, are both things that are very beneficial depending on what the nature of the changed information is, the nature of that deviation. So Industry 4.0 is going to be able to help you a lot here by having that real-time visibility of all of those different things that are happening on the shop floor, being able to immediately see when equipment goes down, being able to identify right away when you have quality issues, even predict when quality issues are going to occur and so forth. And being able to tie that closed loop together of when we're sensing that information from the shop floor, being able to report that into the planning system, incorporate that information, and being able to do a replan can help you keep those schedules that you're passing to the shop floor as current as you possibly can. Now, there's also concerns here in terms of if I'm already telling a department that the next job is going to be this different setup type, and so you already have material handling people going out, getting the fixtures, doing your single minute exchange of dies and so forth, so that you have everything ready for that next job. You don't want to necessarily be increasing the cost to your factory by having too much churn in place. And that scheduled churn is, a big concern for, many different types of manufacturing organizations. And so, from that ideal, you want to be able to do incremental planning as much as you possibly can, and only change the plan where disruptions are forcing you to make those changes. So there's a balance there between changing too much and not being responsive to what's happening on the shop floor. And so those are both things that you need to keep in mind as you're looking at creating these closed loop systems. All right, where all of this is headed is essentially to be planning continually in real time. And, there's a couple of different aspects of that. First of all, it's just continually shortening that replanning loop that I just talked about to the point where you're continually planning and you are continually optimizing what is next on the shop floor based on all of the information that you have. The other key aspect of this is being able to utilize machine learning capabilities to learn as time goes on. How do you optimize the facility? How do we learn to identify those patterns that are most effective and really optimize the flow of material through the factory? Those are things that machine learning is very good at. I will be honest, I have not yet found a system that does this extremely well. For me, this is where things are evolving to, but I haven't seen a system get there yet. If you've seen something that you believe has achieved that, please let me know in either the comments or send me an email or something afterwards, because this is something that I believe would help every company out there. And the replanning cycles and so forth are getting faster and faster, but I don't believe anybody has yet achieved this position of continuous planning. And the human aspect here is something that can be very difficult. This is not how planners work today. And so when you have people that have had 20 years of experience generating a schedule for next week or for tomorrow or whatever it might be, and essentially you're saying, okay, now we live in a real-time world and we have all of this information that's continually updating our planning system, and we want you to go out and now make all of these adjustments in real time. I'm not sure how well most planners that I've met in different organizations would be able to adapt to that speed. So I do think that the machine learning aspects here, artificial intelligence capabilities, are going to be extremely important in this type of an environment where you can automate a lot of those decisions as much as possible. I think that you'll still need a human to be able to make certain judgment calls and so forth. But providing as much support as you possibly can with these different systems is going to be very important to make this function as smoothly as possible in those real-time environments. So with that, some closing thoughts here. The first and most obvious impact of Industry 4.0 is just to improve the information that's available to planning. Just having it as another source of data to improve the accuracy and the completeness of the information being fed to the planning system is just kind of a no-brainer benefit here. The second thing is that having those systems in place that help reduce the sources of variation in executing the plan are going to make your planning results that much better, because anything that you can do to reduce those deviations from the plan are going to help make that plan much more effective. And then finally, as you can shorten those replanning cycles and eventually get down to that real-time planning, that will have significant benefits over time for reducing all those things that we talked about up front in terms of why you want to improve planning, minimizing your cash-to-cash cycle time, minimizing inventories, keeping your key assets running as fully utilized as you possibly can, et cetera. And so, chasing that goal and continually planning faster and faster and utilizing more and more of that real-time information is something that everyone should be striving towards. With that, I thank you very much for today. I don't see any questions in the chat or the Q&A, so I'm going to end this here. But if you do come up with any questions, please reach out to me at visualdecisions.com or my phone number there. I will have this information posted on the website. If you want a copy of the presentation, please don't hesitate to reach out to me, and I will follow up with you to get that off. So thank you very much, and I look forward to our talk next week. Bye.